Hello everyone, welcome back to Amin Maths Club. Today we have a nice exponential problem, that is a to the power b minus b to the power a is equal to 17. So here we have to find the value of a and b, but we have to know that here we have a and b belongs to positive integer. It means that a is greater than 0 and b is also greater than 0. So now starting our solution here, our problem is a to the power b minus b to the power a is equal to 17. Now if we just write a to the power b whole to the power 1, so there is no difference, then minus b to the power a whole to the power 1 is equal to 17. As we also know that this 1 can also be written as 1 over 2 times 2. So cancelling 2 with 2 we get the same result. Now substituting this one here. So a to the power b whole to the power 1 can be written as 1 over 2 times 2. Similarly b to the power a whole to the power 1 over 2 times 2 is equal to 17. Now here, according to this law, that if we have a to the power m whole to the power m, then it can be written as a to the power m times n. So here a to the power b times 1 is b over 2 whole to the power 2. Similarly, b to the power a over 2 whole to the power 2 is equal to 17. Now let us suppose that this a to the power b over 2 is equal to m. Let's say it is equal to m, and b to the power a over 2 is equal to n. Now substituting these values, then our problem will be a to the power b over 2 is equal to m, so it will be m squared, and here it is n squared, which is equal to 17. Now according to this algebraic identity, that if we have a squared minus b squared, then it is equal to a plus b times a minus b. So here we have m plus n times m minus n is equal to 17. Now m plus n times m minus n is equal to 17. Here actually we have that we know that if a is greater than 0 and b is greater than 0, then we can also write that this m and n, it is also that greater than 0. Now if we just make the factors of the 17, all possible factors of the 17, so 17 will be that 1 times 17, and 17 is 17 times 1. But here we see that this m plus n is actually that greater than m minus n. So it is our greater factor, it is our greater factor, and here it is our smaller factor. So then we just take those possible factor of 17 in which first factor is greater and the other factor, second factor, will be smaller. So if we see this one here, it is 1 times 17, so 1 is less than 17, we are going to just reject this one. And here first factor is greater, second factor is smaller, so we just take this factor of 17. Hence we have m plus n times m minus n is equal to 17 times 1. Now by system of equation, this m plus n, which is greater factor, is equal to this greater factor, which is 17. And similarly if we just write m minus n is equal to 1. Now if we just add these two equations, so we have plus n will be cancelled with minus n, so m plus m is 2m, which is equal to 17 plus 1 is 18. Now dividing 2 on both hand side, then we get, here we have 2 cancel with 2, so value of m is equal to 2 nines are 18. Then we get m is equal to 9. Now we can also find the value of this n. So for finding the value of m, we just use that m plus n is equal to 17 and m minus n is equal to 1. Now if we subtract these two equations, then we get here the symbol of m is plus, so we just write here minus, m minus will be plus, so here plus will be minus, just converting the sign from positive to negative and negative to positive. Then we have this plus m minus m is cancelled, so n plus n is 2n, which is equal to 17 minus 1 is 16. Now dividing 2 on both hand side, then we get n is equal to 2 adds are 16, so we have the value of n is equal to 8. Here m is equal to 9, but we know that according to our supposition that we have a to the power b over 2 is equal to m, and here comparing these two equations, then we get a to the power b over 2 is equal to 9. So now if we are going to just stack squared on both hand sides, so we get a to the power b over 2 whole squared, that is equal to 9, that is equal to 9. So here we have that a to the power b over 2 whole squared is equal to 9 squared. Then cancelling 2 with 2, we get a to the power b is equal to 81. Now here we have n is equal to 8, but we also know that here we have b to the power a over 2 is equal to n, but here the value of n is 8. Then we get b to the power a over 2 is equal to 8. Now taking squared on both hand side, then we get cancelling 2 with 2, so b to the power a is equal to 64. Now as we have to find the value of a and b, so for this purpose we have to just write here a to the power b, as a to the power of b is equal to 81. So if we just write the factors of this 81, which will be that 81 is actually 81 is equal to, that is, let's suppose 81 is equal to 3 to the power 4 is equal to 81, 9 squared is equal to 81, and 81 to the power 1 is equal to 81. Similarly 64 can be written as that 4 to the power 3 and 8 squared is equal to 64, and 64 to the power 1 is also equal to 64. Now here if we just take these factors here of 81 and 64, then we can write a to the power b is equal to, this 81 can be written as 3 to the power 4, and b to the power a is equal to 64 can be written as 4 cubed. Now we see that here base is a is equal to 3, and here exponent is a is 3, here base is b2 is equal to 4, and here exponent is b is equal to 4. So comparing bases and exponents, then we get the value of a is 3 and value of b is 4. So it is our final values of a and b here. Now that our final answer is a is equal to 3 and b is equal to 4. So it is our entire solution. Now we are going to just check our solution here step by step. So that's it for today. Don't forget to subscribe my channel for more interesting contents. Thanks for watching. Have a nice day. Goodbye.